Good morning, class. By now, you must be clear with the facts that when solid changes into liquid, it requires more energy. When liquid changes into vapor or gas, it changes. During this change, it also requires more energy because it is being converted into something that should have more energy. And when gas is converted into liquid, from larger energy to lower energy it is coming, so energy is released. Again, when liquid converts into solid, energy is released. So condensation is a process where gases convert into liquid. Okay, so yeah, you know a lot of examples. You take out water from fridge, so there are droplets on the glass. That is because air drops condense on the glass walls, which are very cool. During winter season, window panes have water droplets, and there are a lot of examples you might have seen. Grass have dew drops during winter seasons. Okay, so these are the examples of condensation. So you should know now that during condensation, what happens? Vapors or gas molecules are being converted into liquid. Therefore, energy will be released during this process. Okay, so here see it is written, thus the vapor, when a vapor is cooled, its particles become slower and move in close enough to be held together by the intermolecular force. Thus the vapor condenses or changes into liquid. So during this process, what is happening, that when the energy is released, that means now they have lesser energy. Therefore, what happens, they become very slow and they start coming together, and the force between them is now enough to bind them together. Okay, so they convert into liquid. That means say instead of cooling them down, the other way of changing gas into liquid can be compressing them. If we compress them so much that the molecules come close together, then the intermolecular force will start acting. Uh, that will be enough to keep them close, right? So they will convert into liquid. So instead of cooling them down, we can also compress the gas molecules. This is what is done in LPG, the gas cylinders we use at home. The gas inside the cylinder is in the form of liquid. That is why it is called liquefied petroleum gas, LPG. So it is in liquid form. And how it is done? A large amount of gas is compressed. It becomes liquid when it is in the cylinder. Okay, it is compressed into a cylinder. Right? If that gas is the whole cylinder, just imagine if it is released, how much gas will be releasing out. Right? So that amount of gas, a lot of gas is compressed inside this small cylinder. So due to that compression, that gas becomes liquid, and as soon as you open the knob of your cylinder, it just suddenly instantaneously comes into the burner, because it the compression is released. So the gas molecules or the molecules of that substance want to move apart, so it again converts into gas, and instantaneously it comes into the burner. So as in the case of freezing, heat is given out during condensation. so in the process of freezing, what happens, solid changes into in the process of freezing, liquid is converted into solid, so heat or energy is released. In the same way, condensation also, gas is converted into liquid, so heat will be released. Okay, so when we cook, we cover the lid, because what we do, we try to convert the vapor which is releasing during the process of heating. The vapor is converted again into liquid form. So what happens, energy is released, and that is used to cook the vegetables or other things. So whenever if vegetable is being cooked, you can simply open the lid and see that it is all covered with water droplets. That is condensation is taking place over there. Next process is sublimation. Sublimation is the process where solid changes into vapor. It does not go through the liquid state. Okay, solid directly converts into vapor. And the best example is camphor. If you burn camphor, it won't change into liquid state. It will suddenly directly change into gaseous state. And even if you don't burn it, just leave it somewhere open, slowly it will, you can see the camphor balls will reduce into smaller size, because it is converting into vapor continuously. Same is the case with naphthalene balls, you might have seen at homes. People keep in almirah, etc. Naphthalene balls also, or odonil we use. What happens, these are solid things and they directly convert into vapor. They don't convert into the liquid state. So just imagine, we said that when solid is converted into liquid, it was releasing energy. Liquid was converted into vapor, it was sorry, solid converted into liquid, it required energy. I meant to say liquid has a lot of energy than solid, and gases again have a lot of energy than liquid, right? So in order to convert from solid to liquid, the material required a lot of energy, and in order to convert from liquid to gas, again it required a lot of energy. So now we have to convert solid directly to gaseous state. That means it requires more of energy, a lot of energy, and that energy will be equal to the sum of energy that was required to convert into liquid from solid state, and then from liquid to gaseous state. So here you can see energy of sublimation is equal to energy of melting plus energy of vaporization, right? And there is a process opposite to the process of sublimation where gases directly change into solids, that is called desublimation or deposition. Okay, here the energy given out in desublimation is the sum of the energy given out in condensation and the energy given out in freezing. This must be clear to you. Now gas is converted into solid, so it will release a lot of energy in order to become solid, right? So here you can see examples are given. Camphor, naphthalene balls and air fresheners like odonil are common examples of solids, and that is how we can smell them from a distance, because they are directly converting into vapor state, gaseous state. Dry ice, that is solid carbon dioxide, is another example of a solid that sublimes. That means it dry ice, solid carbon dioxide, it directly converts into gaseous state. It is used to preserve and transport frozen food, partly because it does not melt, and so it does not create a mess. Okay, dry ice, it will be very cold, na, because a lot of energy has been released to convert it from gaseous to solid state, and so it is used to preserve food material, and because it won't convert into liquid state, so there will be no mess over there, so they use it more often. Ice too can change directly into vapor under certain conditions. This happens in the case of glaciers and in what is known as freeze drying. Okay, so glaciers, the in case of glaciers, the ice directly converts into vapor form. Freeze drying is a process of dehydrating perishable things so that they can be transported or stored without having to be refrigerated. Okay, the substance is first frozen and then the water in it is allowed to sublime under certain conditions. So these substances, food materials, are first frozen and the water is allowed to sublime. Okay, that is, it will directly convert into gaseous state under certain conditions, so they do not get rotten. Okay, A natural example of the desublimation of water is frost. What is frost? The snowy thing that covers uh, window panes or uh, the different places, surfaces in very cold places, right? The there what happens, the vapor is directly converted into solid state. Like we have in winters, what we find, that everything, the car surface and everything is covered with uh, small water droplets, right? Because the gases are or the air is converting into water, in the air is converting into water droplets. But in very cold places, what happens, that water vapors which are in the air are directly converted into solid, and that is called frost. Okay, so this is the process of desublimation. Okay, so this is the chapter. So I will stop the video right here, and I'll be sending another video where I wanted to explain you the graph which we have discussed in the previous lecture. So right now I'll end this video. So that's all in this chapter. We will be discussing the question answers etc. in the next lecture.